So I think let's try to kind of demystify a bunch of words that people have heard about blockchain, right? I think most folks today, when they hear about blockchain, I think the definition that most people hear is it is a decentralized and immutable ledger, right? So I think let's try to break this down, and I think really make sense of what that actually looks like. So I think the example that I usually like to take is that of like a notebook, right? So let's say you have a brand new notebook, right? And each page of this notebook, let's say hypothetically, has 20 lines, right? And let's say the whole purpose of this notebook was to basically record every transaction that a bunch of people on a network were kind of performing, right? So in that case, person A makes a transaction, we make an entry into that first page, right? And so on and so forth until 20 transactions are made, and at which point you essentially have filled an entire page, right? So to give you some analogies, a page in this example is what we will refer to in the blockchain as what we call as blocks, right? So you've got a page, the page has a fixed size, which is about 20 lines in this example. And so we can go on and start kind of appending 20 odd transactions to this chain, right? Now, what we then do is on the next page, right? On the next page of the notebook, what we then do is we basically add up all the transactions that are there on the previous page, right? And we run it through, at least in computer science, it's what's called as a hashing algorithm, right? So essentially what we do is we run those past 20 transactions on the previous page, run it through this algorithm, and then now we have this completely unique output, right? It's just a random set of alphabets, and that output is basically pasted on the top of the next page, right? And then from there on, we then continue to then follow the same method, which is every transaction you keep writing down a transaction on each page. So let's now break down kind of what this means, and how we then come to some of these other terms like immutability and decentralization and so on. What is immutability? Immutability essentially refers to the inability for anybody to change any transaction that has already happened in the past, right? So let's take a look at what would happen if someone were to change a transaction on the previous page, right? So let's say on the previous page, let's say there was a bad actor, and he somehow managed to go and alter a transaction on the previous page. So what you can quickly see is if someone were to alter that transaction on the previous page, that net hashing output that we got from the end of that page, which basically factored in the original set of transactions, that gave us a particular output which we now have on the next page, right? But if a bad actor had actually changed one of the transactions, when you recompute the hashes will in fact not match, right? Because the transaction has been changed, and hence because of that, the new hashes will not match, and hence the blockchain will immediately realize that this is actually a nefarious transaction, and it will reject the whole thing, right? So this is kind of how blockchains achieve immutability. It's kind of like each block is basically a block comprising of a set of transactions, and then each block is linked to the next block by this kind of random hashing algorithm to produce an output, and that's what we call as kind of nonces in the blockchain world. So this is kind of how we achieve immutability. Okay, so now let's kind of summarize. So now we've got the notebook, which is the kind of akin, or each page in the notebook is similar to like a block. When you hear about things like block size, that is akin to me stating that this notebook hypothetical example has 20 lines. Typically in the Bitcoin blockchain, you again have certain block sizes, and then every transaction is added, and then we finally got a hashing output, and that adds the hash to the next page or the next block. And this ensures that each block is linked and that no one can go and change any old record, right? So this is fundamentally how a blockchain works. Let's look at what are the types of blockchains, right? So I think when we look at blockchains, I think blockchains can largely fall under two buckets, right? They can either be private blockchains or they can be public blockchains. Public blockchains are some of the blockchains that I'm sure you guys are aware, things like Bitcoin, Ethereum, Solana, Binance Smart Chain. These are all what we call as public blockchains. And then there are private blockchains, things that maybe large enterprises use, blockchains like Hyperledger, R3 Corda. Yeah, so I think these are two of the main kind of blockchains used in the private space. What is the difference between a private blockchain and a public blockchain? So I think let's dive in a bit more. So private blockchains, when we look at them, so when we looked at this whole, we talked about blocks in our earlier example. We talked about transactions adding. So I think to really make this differentiation, we now need to get into details as to who in the network actually has the rights to actually write a transaction, right? To write as well as read a transaction. And I think that's primarily the differentiation between private and public blockchains. In a public blockchain, by definition, anyone who is willing to participate in the Bitcoin network is free to kind of write transactions to the chain and participate and read it right off the chain. Versus in private blockchains, largely that role is reserved for enterprises and entities that you want to be part of the network and so on and so forth. And so there it's a much more regulated environment, versus in the public blockchain, essentially anyone is free to kind of participate and kind of write and have right access. So I think this is largely how we differentiate the two chains. Now that we've kind of understood what private and public blockchains are, let's talk a little bit about cryptocurrencies. I think there's a lot of kind of misinformation in the market about what is a cryptocurrency, what is a blockchain, are they both the same, are they different, and so on and so forth. So I think let's put that to bed. So I think first of all cryptocurrencies are based on blockchain technologies, and the differentiation is that not necessarily all blockchains have a cryptocurrency element, right? So I think in our previous segment, we spoke a little bit about private blockchains. So in private blockchains, for example, you do not actually have a cryptocurrency element, and we'll come to why that is. And obviously in public blockchains, such as Ethereum, Bitcoin, and so on and so forth, there is clearly a kind of token, a public token element, which has a value and so on and so forth. And I think this is the fundamental difference, right? So now, why is there a cryptocurrency element? I think this boils down to the last part of what blockchains are, right? Which is, I think you guys have all heard about this, the keyword, which is blockchains are decentralized, right? Decentralized networks. Now, what does a decentralized network mean? Fundamentally, decentralization means that any network is not being controlled by one person or one entity, and rather decision making is spread out to multiple people who are contributing to the network, right? So in the case of private blockchains, I think this needs to be looked at from a point of what is the purpose of the network. So a lot of the networks, for example, let's say a private blockchain that was focused towards, supply chain of goods. In that example, there would be no cryptocurrency because I anyway know who my participants of the network are. They're probably large enterprises, companies that work with me on my supply chain and so on and so forth. And hence, we'd have much more standardized contracts, etc., that define kind of how we want each member to engage. And hence here, there is no need for any additional cryptocurrency element. Now, if we look at the same thing on something more on a decentralized network, let's say we'll take the example for Bitcoin. Now, obviously for Bitcoin, the goal is we want a network that is not controlled by anybody. So in this case, you want a network and a kind of operating model where there is an underlying kind of incentivization model that is providing some incentive for people who have nothing really directly to do with Bitcoin itself, right? You want people to participate in the network, run validator software to basically provide a service to the network, right? And I think it is fundamentally to incentivize this activity, this kind of activity of people contributing to a network with no inherent pull towards it. It's almost like it's free for you to decide. And the reason people contribute to these networks is because the network pays out a monetary reward, right? And that monetary reward is in the form of the native currency. So let's say if you are performing a service for Bitcoin, you'll get Bitcoin currency, and if you're doing it for Ethereum, you'll get Ether currency. And I think these people who earn these native currencies, they are essentially what we call as miners. So I'm sure you guys have heard of Bitcoin mining and Ethereum mining. And essentially, these are the folks who are actually running scripts that do the kind of validation job that a traditional bank would do, right? Checking whether X account has X balance, is the account address right, and doing these checks and kind of settling it. So I think these are done by decentralized, people who have, it's not like they're being hired by Ethereum or Bitcoin to do this. They do it completely free of choice and for this economic incentive, which is in the form of cryptocurrency. And I think that is fundamentally why you need a cryptocurrency element whenever you are trying to build a fully decentralized network, versus if you are building a private blockchain, then you actually don't need any cryptocurrency element. Yeah. So I think crypto can largely be defined as a digital asset that lives on a blockchain, right? And I think uh, whether that crypto is decentralized or centralized, I think is more specific to the particular design choices of that particular cryptocurrency. But fundamentally, crypto is the way I see it. It's just basically a digital asset that lives on the blockchain, right? And I think what we've seen over the years is there are cryptocurrencies that offer various types of utilities to us as consumers, right? So you've got stable coins. Stable coins are also a subset of cryptocurrencies, except these are mimicking our real world currencies like dollar and pound, etc. You've got the utility cryptocurrencies. These are cryptos such as Ethereum, which offer an actual real world use to us as users. In Ethereum's case, that allows basically developers to build applications on top of the Ethereum ecosystem. And then you've also got kind of security based tokens, which are cryptocurrencies that mimic things like stocks and equities and bonds, etc., in the real world, right? That are actually paying you a dividend simply for holding that. So I think that's in a nutshell how we define cryptocurrencies.